Okay, chapter 20. We've got a simple random sample of 500 female, 550 male. They're asked if she worked for pay last summer, and we've got some numbers on that. Okay, PM and PF are the proportion of males and proportion of females who worked for pay. We conjectured before seeing the data that men are more likely to work. What's the hypothesis be tested? Well, H0 is that they're always equal. Men are more likely. That means the proportion of men is greater than the proportion of females, so that's going to be B. 10. The sample proportions of college males and females who worked last summer are about, well, for men, is going to be 550, let's see, 484 out of 550, and the proportions of female, it's going to be 410 out of 500, and then whatever percents those are. So 484 divided by 550, it's going to be 88%. That's the males. So PM is 88, so that's going to be this guy right here. And just to double check, 410 divided by 500 is in fact 82%, so we're good on that one. Okay, 17. Truthfulness in online profiles. Many teens have posted profiles on sites such as MySpace. That pretty much tells you how old this book is. Sample survey asked random samples of teens with online profiles if they included false. Of the 170 younger teens, 117 said yes. 317 they said yes. So we've got your two samples. So you got younger teens. So you've got 117 out of 170, and older teens, you've got 152 out of 317. And the question is, do these meet the guidelines for large sample confidence to make a confidence interval? As long as it's a random sample, or the sample is a sample size large enough. And let's just kind of look at the percents here. What percentages are we dealing with? We've got 69% of the younger teens, and 152 divided by 317, 48%. Are these samples going to be large enough? And the answer is absolutely yes. Large enough to continue. B, give a 95% confidence interval for the difference between the proportion of younger and older teams. So we want, so if I call this PY hat and PO hat, we want the difference between younger and older. PY hat minus PO hat plus or minus Z star. And then this is PY hat, QY hat over N plus PO hat, QO hat over N. Now, we're going to make a confidence interval here of this. So I'm going to, instead of plugging all the numbers in here, rewriting it, we're going to substitute these into here, and it's a 95% confidence interval. So I'm going to go ahead and just do this on the calculator. Oops. There we go. I'm not sure. There we go. Stat. Tests. 2 prop Z test. Okay. So this is always going to do x1 minus x2. So x1 is the younger. So we're going to do 117 out of 170, x2 is 152 out of 317. Oh, I'm doing a test. We want a confidence interval. I know you're probably going, what are you doing? two proportion z interval, and it saved my data. That was very nice. And I can't remember what level it said. 95. Okay. So there it is. 12 to 29.7. 12% to 29.7%. So the difference between younger and older teens who include false information is somewhere in this interval. So these are always a little trickier to write. I'm 95% confident that the true proportion of younger teens who include false info is between 12% and 29.7% greater than older teens. Now that's much better or easier to understand, I think, than saying the difference is somewhere in this interval. I think this just makes sense to say the true proportion of younger teens who include false information is between 12 and 29% greater than the older teens. Does that make sense? Okay. All right. And just to be clear, we're going to talk about this more in class. Why is this large enough? Because we really haven't hit on this a ton in class. We talked about what does large enough mean for means, but we're going to come back and talk about for proportions more in class on this. Okay. And that's it for this video.